In this video I want to talk about type classes. Also I want to talk about multi-parameter type classes and functional dependencies in these type classes. The type class. A type class is like an interface in an imperative language. Strictly speaking, type class is defined by a set of polymorphic functions which we can apply to some group of types. So we need to take some group of types from all possible types, and for every of these type we need to provide an implementation for this set of polymorphic functions, for this interface. And then we have all these implementations for all of these types. We can abstract with this polymorphic function with this interface defined by these polymorphic functions with all this group of types, with all this class of types. Okay, so type class provides for us some kind of polymorphism which defined by this interface, and this polymorphism is restricted by the certain types which present in this group. Let's look at some example. I have two types here. I defined them by myself. Okay, the first type is Boolean type, which defined by two constructors, two null constructors, true and false. And I have a bit type, which defined also by two constructors, 1 and 0, 1 or 0. So these types are isomorphic to each other. And I want to define some type class for these types. So I want to group them in some group, in some class, and provide some function, polymorphic function, which applicable to any of these types. So I have two these types, and I want to somehow combine the values of these types. And for function in my type class, I will use a logical OR operator. I will name it with these signs, these lines, 3 lines. Okay, and I defined a type class as with name logical, and it takes one argument. So we start with a single parameter type class, and later we will see it multi-parameter type classes. Okay, what is a OR function? OR function takes two values. Each of them are values of the same type. We take some value of type A and the next second value of type A and produce a value of type A. So it must work as logical OR. So if one of these values is true, we return true, otherwise we return false. So I define this abstract type class here, which which says that if I have some type A, I have some polymorphic function for this, some polymorphic operator for this type A. But this is very abstract. I mean that these two types are not somehow binded to this interface now. To bind them to this interface, we need to provide the instances of this type class for these types. So let's start to define instance for Boolean type. Now I need to implement the instances for this type class. So instance logical for Boolean, and here we need to define the function. It takes this function and it takes two arguments. If the first argument is true, no matter what the second argument, we must return true. And otherwise, if the second argument is true, no matter what the first argument, we return true. And if we have no matter otherwise, if no matter what the arguments are, we must return false. And this implementation for Boolean type for our logical type class. And also we need to provide implementation for bit type. It's because types are isomorphic, it's the same. We just need to change the constructors names. So one here, one sorry, I need to logical bit here. Our type class logical, our type is bit. Okay, 1 1 1 1 and otherwise 0. Okay, now we have two these instances for our logical type class. Let's reload. Let's load our module. Okay, it's loaded. And now let's check how this works. True or false? We return true. Okay. False or false? We return false. And for example, 1 and 0. We can also combine our bits and we can combine our booleans. But what if I want to combine boolean with a bit? What will I receive? Okay, you can see that we have some error because we have no implementation for such pair of types. We can only combine the types of the same type, and this problem can be solved with multi-param type classes. Okay, you need to add this pragma in the header of file to enable the ability to define a type class, multi-parameter type classes. So let's define some of these type classes. The next thing I need to do here, I need to redefine this class. So our logical type class take only one parameter, type parameter, but we need to add some more parameters. I will call second parameter b and the result parameter c, and our function signature will also change. We take as a second argument this type b and return type c. Okay, this is our new type class definition, and also we need to change these instances. So we need to add some we need to define also a, b and c here. So a is boolean, b is also boolean. Let's define when the combine at first when they combine two arguments of the same type. This type is boolean. So I take boolean, and I produce a boolean. A boolean, b boolean, and c boolean. So in this type of implementation, we have the correct implementation, I think. Yes. And also for bit, if we take bit and second argument is bit, we produce a bit. And this implementation also correct. Let's try to reload our model. Okay, model is loaded. Okay, now let's try to use our type class. What if I try to combine true and true? And you can see they have error here. And let's look at this type. The expression has this type. It has some type C, which must have a logical type class of boolean, boolean, and C. But we didn't know which this C. Because here we have instances only for certain types. We have boolean, boolean, and boolean as a result, and bit, bit, and bitten as a result. And if we have here A as boolean, B as boolean, we need to define C. But C is undefined, and compiler can't know which C, which type of C has. If we can see in the source code, we can see here that we have boolean, and we can ask why compiler can't know. I have boolean here. Okay, let's guess that result C is boolean, but it can't, because we can also add here implementation of such kind. What if we have a boolean type and bit as a result? We can implement this. We have 1 here as a result and 1, and 0 here. And you can see that this situation here becomes ambiguous. It can choose any of these or these, but it can't. And also I didn't want to do multiple variants of the result, Boolean bit. I want to provide some canonical result which will be represented as Boolean. And to calculate this expression, I need to define its type. And if I said that its type is Boolean, then if I assert this type to Boolean, then it will evaluate to true, because now compiler can see that it has Boolean as a result, and it chooses this implementation. You can see it this type. We have no ambiguity here. So we can avoid this explicit type setting to our expression. For such a thing, we need to use the functional dependencies. We need to add this pragma here, and if when they add this, we can remove this, because functional dependencies automatically turn on multiple parameter type classes. Let's remove this, and here I need to make some assertion. I say that if I have A and B, then C is uniquely determined by A and B. So here I said to compiler that if you find in the source code A and B, so in our case this Boolean and Boolean in this case, then you can uniquely determine C. So if we have this Boolean and Booleans, then this is determined. So I said that we will not provide any implementation with some other C's others than Boolean. Let's try to reload and calculate this without our explicit type setting. Okay, and you can see that this is worked. Works. And now let's make some other instances to enable different types of params worked with our old function. Okay, so I want to make work things like true and 0. Okay, this is not work because there is no implementation for logical Boolean and bit. Okay, and I need to provide these implementations. And let's do this. Okay, I copy it and paste it, and here I have Boolean and here I have bit, for example. I need this implementation, and also I need bit and Boolean implementation. Okay, if I provide them, I will be able to evaluate such kinds of expressions. Okay, let's implement them. If I have Boolean here and second is bit, So one here. Okay. And the next implementation. I have bit here, so one here and boolean here. And this should work. Let's reload, and you can see that it works. Okay. Now I make my function more polymorphic. It can be used with separate types of arguments. Other cases, for example, false and 1. Okay. And 0 and false. Let's false. So it works as expected. Okay. Let's look at our definitions here. Okay, thanks for watching. That's all. Sorry for my English. I hope it's not interfere for meaning. Otherwise, please let me know. I try to fix it. Anyway. I try to improve my English. Thanks and bye.